trivial, right? That example was simple. So you can say I have my variable set it as text. Correct, that's straightforward. You say it's the user.image, the source, I call set source, which I said before, which does not exist. So this is a problem because the image view doesn't have a set source method. It has a source attribute, but it's a set image drawable method where you can pass a drawable. How does data binding know about this? It's done by annotation. So we have this binding method annotation, where you can say, okay, this is a binding annotation for a type class image view. The attribute is source, and the method is called setImageDrawable. So that we know that attribute source maps to setImageDrawable. If the pass parameters match, we can use that method to run the binding. Again, this is done in the compile time. What we generate is the same code that you will do at setImageDrawable. What the event handler? So these are a little bit tricky because unfortunately Java 7 didn't have any function parameters. You cannot do them. So the way this works is, again, we know there's a binding method that says onClick matches set onClick listener. And we look at, okay, what does the set onClick listener expect? Oh, it expects a view.onClick listener. That's an interface, or great. And then the interface has one method. Then we look for that handler.clicked matches that one method. So going in details, we saw this, and then we saw this. OK, nice that the handler.click method receives a view, and this matches. So we create the interface for you so that Java is happy, and then we are going to tunnel those calls to your handler. So you can see everything is matching. It just works. Oops, too fast.
Stealing my thunder here.
All right, binding adapter.
Let's talk about binding adapters. Binding adapters are probably the coolest part about data binding. So let's talk about something a little bit more complicated than set text, right? Set text was a nice automatic variable. You can just set text, it takes in a string, or actually text takes in a char sequence, but it's pretty close. But let's talk about something more interesting. We have this image view, but we have a large URL, like a large image data coming down. And if we do this, what's going to happen, right? We don't want this on the UI thread. It's going to load everything on the UI thread. That's pretty lousy. I don't like that.
Why not?
So instead, I'm going to use a tool. How about Picasso, right? Or Glide? What's your favorite?
I'd rather not say that.
All right. In this example, whoever it was who wrote this expression tried to use Picasso, but my goodness, Picasso with context load, that's a heck of an expression. And into what do you do? I don't know. That's loud.
You can have an expression language. Why not?
I don't like this. This is just too. We don't want to see that in our expressions anyway. So let's do something a little simpler. Instead, what we're going to do is create a binding adapter, and we're going to use the Android source. We're going to override what the default behavior is with our binding adapter. And instead of doing the normal stuff, we're going to try to do something special. So what we're going to do is set this binding adapter. Of course, this is an attribute, an annotation on our static method here. And it can be any static method anywhere. And we're just going to look for that static method with the attribute, the annotation. And here we're going to look for something that is an image view, and it takes in a string as a parameter. Okay? And now what we can do is do anything we want in that class. So we have this nice Picasso. We can use the context from the view. We can load the image in there, and it can be done all off the UI thread. And it's all kind of magic. Now you can do image source is equal to some value. It's great. But what if you want to do something more interesting? Let's imagine you want to have a placeholder for your annotation. Now, you have to do this with Picasso in the same call, right? You can't just say, in one call, call the load, and the other one you do. So what we're going to do is we're going to merge it all together into one binding adapter. And this one takes two kind of attributes, and they can work together. And you just take the parameters in the order that you've assigned them in the annotation. And now you can do whatever you want in the method. In this case, we're going to load the URL off thread. And in the meantime, we'll load this placeholder image. Now, sometimes you want to have some kind of instance information in your adapter. And before, we were using static methods, right? But what happens if you want to use an instance? Right? There's a static method. It's easy. We know what to do. We can call it directly, just myClass.static. static method call, very simple to do in your the generated binding class that we have.
How do you get the instance?
So yeah, I mean, we take out the static, what happens? Where does that instance come from? We have to do some kind of instance. So what we're going to do is the binding framework is going to look and see, oh, this is an instance binding adapter. We need to generate this method on this class, this data binding component class. And this method is going to be called get, whatever the name of your adapter class is. And now it's your job to implement this method, to implement this class. So you implement this class, and then you call set default component on it. Now there's also ones if you want to load a specific implementation for a specific binding if you want. But most of the time, you probably want just a default component that you're going to load. And then we know exactly what instance we're going to load for your binding adapter. So that's what we released back in the fall. Let's see what new things we have here. Two-way data binding. Now, I know I've heard a lot from you guys out there that say, this is great, but without two-way data binding is useless, right? I can't believe I heard that, but I think even one-way data binding is pretty awesome. So I saw a few people trying to do their own thing for two-way data binding, and they do something like this, where they do the one-way data binding with the regular data binding field, and then add another handler for the text change. And then they have to check, of course, whether the change really happened, or else you end up with this cycle of loops of the text changes in the field in the view, and then goes back to the field, and it sends a text change message. So it was kind of a mess. And you end up having this change handler for every different bound view in your layout. And it really kind of sucked. So we want to do something a little better than this. Get rid of all that stuff that we used to. And we can do this all on our own by just saying @ equals instead of just @ curly brace. Right? The @ equals is just a kind of a nice, quick, and very visible indicator that this is a two-way data bound field. Now we can bind to the Android text field in a very simple way. Now, you may be wondering, how does this notification happen, right? What's going on underneath the hood? This is kind of important if you're going to write your own data bound fields. So the first thing we have to know is what kind of listener should we add. Right? We don't want to use text watcher, right? Because that's only useful for text views or edit text. We don't want to use, I don't know what.
Time change.
Time change, yeah, date change listener or something like that. That wouldn't be good. So we have some kind of generic one. It's called the inverse binding listener. This is basically telling us that there's been a change on your view. And what happens is your binding implements this listener for you. And this is code almost straight out of the generated code. So you can see here that what's going on is it's getting the text from the view, and then it does, of course, null checking, right? You guys have to make sure to do all null checking. Everyone here always null checks their variables, right? Okay, everyone? Yeah.
You're not using data binding, though. You don't need null checks.
Yeah.
It's 2016.
Yeah, that's right. Who has no pointer exceptions? I don't know. Nobody. And then it finally sets the field. You can see here that it's actually setting this field as an observable field. And actually, you might be interested to see that this comment here is actually in the generated code. So you could, if you want to go look at the generated code, you'll see this comment and see what the inverse of this expression is to help you try to debug if you have a problem with it. So let's look at how you get the field's value. We just saw about getting the field's value. And one thing to do is to try to create this annotation, which will give you a getter for your view. So here we have a text view type, and we want to know what is the getter for Android text. Now we have this method. We can just say declare it. It's a get text. But if you don't just supply it, there's a default. And it just uses the attribute name. So even if we didn't supply anything, it would use get text because the attribute is Android text. So it's kind of smart that way. And we have this synthetic attribute. This is for the event. This is the event that notifies that there's been a change in that view. And again, there's a default here. If we didn't supply anything, it would be Android text attr changed. And so most of the time, you wouldn't supply anything here at all. Now I want to talk a little bit more about this. So we, of course, have to get notifications from the text view. And so this is what you'd normally do for a text view, right? You have to set a text watcher. And so we have these event attributes in the binding adapter. And so we just add this other attribute. And we're going to the synthetic attribute. Now, the synthetic attribute, you can't use this in your layout. We check against it. So if you try to do that, it's going to mess up. It's going to throw up a nice exception for you, or error message for you. But anyway, so you can now set this in your binding adapter. And this is, of course, all done for you for all the fields that work. And of course, what you have to do, you have to remove the previous one, and then you have to add a new one. And you have to notify them only if they're not null, right? We don't want to notify null things, because we, of course, want to do null checking. And we also have to notify our onChange lister. So now we know that when that text view changes, it's going to call our generated onChange. Now, if you have a more complex getter, well, this is not very complex, but this is a little bit more complex, right? The text view doesn't return a string. It returns what?
Char
Yeah, char sequence, right? Yeah. And who here uses char sequences? Nobody uses char sequence. If you try to assign a char sequence to a string, typecast error. So this is a little more convenient. So you have a get text string, which will automatically convert your char sequence into a string. And so this kind of thing will help you with that. And again, we have this attribute. And the other field is also there, the event, and it's automatically defaulted. Now, we talked a little about these cycles before, where if you have a text view, or an edit text, and it makes a change, of course, it's going to change your data field. And if you have a change in the data field, it's going to change your edit text. Now, that really sucks, because what happened? User typed A, and now it just set the text on that again, and you lost your cursor.
Yeah, something you will realize, if you set the text on a text view, even to the same text, it will still call the change watchers, it will still invalidate the layout, because inside text view is actually a different spannable string. Like, it has some other format, so we have to do that.
Yeah.
So data binding gets you covered. How is that?
Well, actually, it's going to do more now, because it just recognized that there's another change, and of course, it's going to send another text change. And it's going to keep on going on and on. And that kind of sucks. Nobody wants to see infinite cycles in data binding. So let's solve it. We're going to solve it once and for all, right? Well, unfortunately, no. But you can solve it. And we just solve it for all of the ones we've implemented. You just have the check in the binding adapter that says, when you set the text field, we check the previous value and make sure that it hasn't changed. If it has changed, then we'll just set it. If it hasn't changed, then we don't set it. And that breaks the cycle before we can get this kind of infinite loop. Here.
So these kind of solutions we do in data binding, like instead of changing the framework, that's an option for us, but it will only work in the new devices. By doing these workarounds, we can support data binding, like API 7. Right?
API 7, that's right. Yeah. So does this work on all attributes? Well, no, clearly not. Because we need events. We need events to know whether the field has changed, whether the attribute has changed. And so we only work with the ones that have attribute change events. So like text watcher, like checked changed. So these are external events. These are not on whatever changed events. So the good thing is that almost everything you care about already has a change notification on it. These are the things the user is clicking on, right? They're typing in the edit field. So this is great. So we already have notifications for these, so that will work for almost all the views, all the attributes that you really care about. But if you have your own views, you need to do this, have an external event that you can set a listener on. All right. Let's talk about a little bit about expression chaining. Now here I have a layout with 3 views, and they all have the same expression in it. It's kind of ugly code. Like, it's all UI code, but it's a little ugly, and I really don't want to do that. I'd like to have it once and then reuse it elsewhere. So what I can do is create an ID that I can later use in my other expressions. So now we can just bind to another field. It's pretty nice. What it's doing under the hood, of course, is just saying, oh, I recognize that one. We already had a bound expression there. I'm just going to substitute that. We also have implied event updates. So you can bind, for example, to a checked field in another view, because checked is a two-way data bind field. So we can just say, oh, look, that field over there was, the user clicked on it, and we get an update right away. We know what happened. Let's talk a little about Lambda expressions.
So two-way data binding is one way of grabbing the data from the layout back to your data model. Another way is the callbacks, right? Everybody wrote this. You get a view, you set a click listener on that. So we wanted to make it a little bit better. So in today's data, like before we introduce this feature, what you will do with data binding is that you would give the view an ID, and then in your Java code, you will get that ID from the binding. We already create the view for you, and then you will set a click listener on that. So we want to make it more intuitive. We got rid of that. We introduced method references so that you can say, hey, when we know onClick is an event, so where does presenter come from? There's actually another variable you declare, so there's still no magic. It's not like the onClick event you have in the activity, in the framework. So in the presenter, what you would do is, so we'll automatically call this method. You will receive the view because the onClick listener receives the view. You will get the binding. So it's a cool method, like data binding util has a find binding method from any view. And then you will get the item from there and then do whatever you want to do with that. But this was still a lot of unnecessary code. So we wanted to make this a little bit easier. We introduced Lambda expressions. So you get rid of that. You can instead just say, when onClick happens, just call presenter save with the item. Where does the item come from? It's the item that you declared there. So in your save method in the presenter, like you can do whatever you want. Now you have the item. What is very cool, actually, the reason why we push, so we had this in the timeline, but we pushed this feature a little bit earlier because the testing team was releasing these like architectural demos from Google. And for the MVVM demo, they wanted something like this. When you do this, the presenter has 0 Android code. You pass it, so your layout file handles everything specific to Android. You can just test your presenter the way you want. This so beautiful separation. It works very well and makes it very clean. Another very cool thing here is that in Android Studio today, you can go in a roll over the save function there, click on it, and go to the presenter. So much easier to navigate the code while you are developing. So I see, let's look at a little bit more details. So it's a Lambda expression. You can also write this, right? The onClick receives a view. So if you look at the description of the onClick callback class, this is how it looks like. So you can actually reference that view in the Lambda expression if you want to use it. And the view inside the expression refers to the one that you declared in the parameter section. It's just like the Java 8 Lambda functions. And now let's say you can actually name it whatever you want. So I name it V. The name doesn't need to match anything. So let's look at another example, a focus change. So you want to know when the focus changes, you want to call your presenter with the, whatever the new focus is. Unfortunately, you cannot do this because if you look at the onFocusChange method, onFocusChange class, the method receives the view and the focus state. So even if you don't want to use the view class, the view parameter, you have to declare it. So the rule here is you either declare all of the arguments that the method receives or you declare none. So we figured out not declaring an argument is a very common use case. Like in the click listener, you almost never want the view anyways. So we want to provide that no argument shortcut. Another example here is onLongClick. Now the difference about onLongClick is it actually expects a Boolean value as a result, so that we know we want to populate it or not. So for this to work, the presenter show many method also needs to return a Boolean value. So we are not going to if you put some Lambda expression there that doesn't return the value expected by the callback, it's not going to compile. We don't want to, it's by default return false, and something breaks in the feature, you have no idea. So if things don't match, we don't try to do magic, we fail. So now there is two ways to do the same thing. There's the Lambda expressions and the method references. They're both useful. I want to go over what the difference is because they actually behave differently. So the major difference between the two is lambda expressions are evaluated when the event happens. So whatever expression you put there, we evaluate it when user clicks on a button or the text changes or whatever. The method references, on the other hand, is evaluated when we refresh the UI. Like when something is invalidated, when we refresh the UI, we evaluate the expression, we figure out which method wants to be called, and set a click listener that directly references that one. So let's look at an example. And on your update UI method, you get rid of all of it. The only thing you do is set it on the binding, and it takes care of it. All of this happens without any performance penalty. The third thing is callbacks. Now, it's always the case, like, you get the binding, you get the fab, and then set the click listener. This also so unnecessary. Just declare the presenter. Just say, like, when this button is clicked, call this thing. The nice thing about this implementation is you can just, when you're in Android Studio, it happens all the time, right? Like, you're going to a layout, okay, like, what happens if user clicks and you try to, like, search references of that view ID and then see where the click listener is at. There's a couple of steps. Here you can just click and go to that method and find the implementation. So especially if you're starting a new app from scratch, observability might be very, very handy. So instead of having this simple user class, you can may extend base observable. There's also an interface if you don't want to extend. You make it bindable. And then whenever the value changes, you notify this change, and we will take care of updating the UI. And there is this, like, one of the new features, like highly requested features, two-way data binding. Now, like, two-way data binding, when you have like complex model, is not very easy to use. But like all of us have like login forms, like all these simple form kind of layouts that people has to fill. And there's a lot of logic going in there. Instead of writing that code, you can just let two-way data binding handle all of it and return you an object. So for a layout like this, all you want to do is like create a smaller class, make all of them observable field. Like you have only one instance of that class. It doesn't matter how expensive it is. So make everything observable field. And then when we do that, our layout will look like this. So we have a validator that enables, disables the button or whatever logic. And you have the form model. And for each of the input fields, you use them. So you say this is the name. Notice that there's a two-way binding. Or you have a button. You say if my validator model enables it, make it enabled. You do this. So like you cannot do this in every single layout, so you need to be careful. But like something this like you could encapsulate is about forms, or like one place you want to grab data. It's so much cleaner, so much simpler, and you will save time. So you just do this. So now you have a binding layout that gives you an object that has the data, and then you do whatever you want to do with that data. So I want to quickly go through some of the best practices, because data binding is very powerful. But just because there's a way to do things with data binding does not mean that you should do everything with data binding. So something you need to be careful when using data binding is what expressions you put there. So like if you put an expression like this, hey, when user click this button, send the money. You should not do this. Like they're so wrong, because like sending the money is completely about your application. This is your business logic. It has nothing to do with your UI. The only thing you care about is that user clicked on that button. This is where the responsibility of data binding stops. So you get rid of this. Don't do that. Instead, put something like presenter on send click, so that like that presenter class can be tested by itself, and then you will have a reliable application. I know it's not very clear where you want to stop, like how much can I data bind and how much I should do in the Java code. Well, you use your intuition, like use what works best for you.
So you're saying change the name of our class, our function, right?
Yeah, that was the goal.
Yeah, okay.
Don't call it function. Use program. That was all. Use program. By the way, data binding works with program because we do everything in the compile time. It's the detail. So another thing is like if it is related to UI, just put it there. I mean, you don't need to. Oh my God, I shouldn't put any logic in my examples. It's like that doesn't make any sense. If it is about how that layout looks, if it is simple, just keep it there, because the important thing is when you look at that layout file 3 months after in Android Studio, then you have an idea what that layout does. That's the point here. Like they should be they should be declarative. They should explain themselves. But if you put an expression like this there, like there is no way you read it and understand what it's doing, right? It's just confusing. Don't do something like this. They need to be simple expressions. So get rid of it. You know, like create a method that gives a short name and then use that one instead. Like if they are not readable, like if you realize they are getting long, then you're probably doing something wrong. So it's a method we created.
Yeah, we can also, something to mention though, is we can also do string functions there. So if you want to do string substitutions, you can use the string formatter right there in your expressions as well.
Yeah. So another thing is recycle views. So by the way, 2 days ago we just published like sample application that uses data binding and recycle view on GitHub, and I sent it into the Spaces link so you can find it there. But one thing you need to be careful about is if you're using data binding with recycle view, which you should because it generates the view holder for you. When you bind a view, you should always call execute pending bindings. You should, if you don't do this, binding will defer it until the next layout, and recycle view will get unhappy because the view didn't tell us how, like, what the height is. So there's a couple of things, like these are a couple of little examples that people did with binding adapters mostly. Wanted to mention them. You can do this. This is like HTML. I have a text view, and it's the image URL. Well, that should be probably an image view. But it's an image URL. And then it just works. You have a binding adapter, you pass it to there, everything is fine, properly implemented, and you know what that image shows. You don't need the ID or whatever to make it self-explanatory. It's visible. Oh, here is an image here. So you can even have multiple parameters, like binding adapters can receive multiple parameters. You can say, okay, this is the placeholder, and this is the image URL. You have a binding adapter that receives these two attributes. We call it with these two values. We even like convert that drawable into an actual drawable. You don't need to do it yourself. And you can have your logic. It works very well with testing because in testing, you just provide a dummy adapter that doesn't do anything. And then now all your tests run faster without making network requests. The other thing, font. This has been requested on the text view for many years. We haven't implemented it until data binding. Now, you could just create your own attributes, call it a font, and then it works. There's actually a project on GitHub from Lisa that does this. It's super cool, super convenient. And you can use vector drawables. So now today you cannot use vector drawables in XML, right? No, if you use data binding, you can actually use vector drawables. You just create the binding adapter for that and do it. Another one here is, like, it's so common in applications. You have dimension like image margin, and then you have something like dimension picture size, and picture margin, so that you can align your views. So you create all these dimensions. You don't need them anymore. You can just use data binding to say, hey, this thing is picture size plus picture margin. That's it. It's like this should have been there already, but it wasn't. All right, so like once you start experimenting, like these are things we did not think about. Maybe the image URL, that was something we thought about, and that was it. Like people came up with this font, the margin thing. So you get like, it's just new stuff you can do with data binding. So go on, experiment with it. Thank you.
Thank you.